Good morning class. Here is a practical related to the LCR circuit which is in series, and we will determine that what amount of frequency is required so that current can pass easily through LCR circuit. So here I am having audio frequency oscillator whose input is being supplied to the resistance, then resistance, capacitor and inductor is in series. So for that I am having apparatus, audio frequency oscillator, LCR kit where in the series LCR circuits are there, CRO that is useful for the readings, multimeter and connecting wires. So here in the diagram I am having audio frequency oscillator. CRO is attached so that we can calculate the frequency corresponding to the voltage in the circuit and current is flowing through that circuit. So here resistor, capacitor and inductor is in series, is in straight line. So milliammeter is there to measure the current. So beta, this is LCR circuit in which I am having audio frequency oscillator at this terminal, and the range for that audio frequency oscillator is 1 kHz, 10 kilo and 60 kHz. Along with that variable frequency means if I put the knob here, that means input is up to the range of 1 kHz, and from here I can choose that frequency, that 0 to 1 kHz, which amount of frequency I require here. That will display here at this terminal. So at this terminal, as it is 0.925 kHz, so from 1 kHz I choose 0.9 kHz frequency for the input. So from here input is being attached to these two terminals. Now here is resistance, and resistance is of 1 kilo ohms. Along with that, resistance is connected to the inductor of 65 millihenry. So that inductor is again connected to the capacitor, and capacitor is of range of 0.01 microfarad. So this is how we can connect LCR. C here, L here, R here. So in the series this circuit is connected, and these two terminals are just for the connection purpose. Same is with this, okay, and the output we will read at this terminal. So output is at these two terminals, that will be here. So here voltage is of 0.009 volt and frequency is of 0.92944 kilohertz. So this, from this voltmeters reading, I can easily evaluate the current, that what amount of current is being supplied to this LCR circuit. So that current by Ohm's law I can calculate V upon R. As by Ohm's law V is equals to IR, so V is here, R is here, 1 kilo ohms. So this is for the series circuit, LCR in series circuit, okay. So this is how you can operate LCR circuit where audio frequency is here, variable frequency, that range from 1 kHz I choose 0.09. This is for the input purpose and this end is for the output purpose, okay. So here I am having observation table where I have marked the voltage reading, that was 0.107. Along with that frequency was of 0.944 kilohertz, that I transform into simple hertz, that 944 hertz. So by Ohm's law V is equals to IR, from that I can calculate the current value, and current is equals to I is equals to V upon R. As resistance was in the circuit of 1 kilo ohms, so that I can calculate easily corresponding to the frequency, that what is the current. So with these terms I can trace the graphical representation where I was on the y-axis and frequency is on the x-axis. So corresponding to that we can trace the graph for the series LCR circuit. So here XL is the resistance for the inductor, that was 2 pi FL, 2 pi frequency into inductance value, that was 66 millihenry. So VL is the voltage for the inductor, Q is the quality factor. So this is how we can calculate easily quality factor value, voltage for inductor and resistance for inductor. Corresponding to that graph should be there. Thank you class.